In this tutorial, we will see the calculations for the simplest waiting line, a system with a single line and a single server. The assumptions for the single server exponential service time model are as follows. 1. There is a single server or a team that services a single customer at a time. 2. There is a single waiting line. 3. Customers are selected based on arrival time, with the first to arrive being the first to be served. 4. Arrival rates can be described using the Poisson distribution. 5. Service rates can be described using the negative exponential distribution. 6. There is no practical limit on the size of the waiting line. System utilization rho is computed as the average arrival rate lambda divided by the average service rate mu. This formula is sometimes shown as m times mu. However, in this case there's one server m, so including the term does not change the formula. The percent idle time I is just 1 minus the utilization. The average number waiting in the queue, L sub q, is lambda squared divided by mu times the quantity mu minus lambda. L sub s is the average number waiting in the queue combined with the average number waiting in the system, so it is always larger than L sub q. It is lambda divided by the quantity mu minus lambda. The average waiting time in the queue, W sub q, is L sub q divided by lambda. The average time in the system, W sub s, is 1 divided by the quantity mu minus lambda. The probability that the system is idle, meaning no one is waiting and no one is being served, is 1 minus lambda divided by mu. The probability of one or more customers in the system is the probability of an idle system times lambda divided by mu, all raised to the n power, where n is the number of customers. In this first example, a smoothie shop has an average arrival rate of 20 per hour during its busy period. On average, servicing a customer takes 2 minutes, so an average of 30 customers per hour can be served. Arrivals follow the Poisson distribution, with service following a negative exponential distribution. Find the characteristics of the waiting line. System utilization is lambda of 20 divided by mu of 30, or 67%. All percentages are rounded to whole numbers. Percentage idle is just the complement of system utilization, or 33%. The average number in the queue is 20 squared divided by 30 times the quantity of 30 minus 20. That works out to 1.33. The average number in the system is 20 divided by 30 minus 20. That works out to 2. The average wait is the L sub q value of 1.33 divided by lambda of 20 for 0.07. This is 0.07 hour. Multiplying by 60 yields 4 minutes. The average time in the system is 1 divided by 30 minus 20. That yields 0.10, also expressed in hours. Multiplying by 60 yields 6 minutes. The probability that no one is in the system is 1 minus 20 divided by 30. That yields 0.333, or 33%. This is the same as the percent idle calculated earlier. Using the idle probability of 0.333 and multiplying by 20 divided by 30 to the first power gives us a 22% chance of one customer being in the system. In this case, they would be receiving service. Changing the 1 to a 2 gives us an almost 15% chance of 2 customers being in the system. That would be one in line and the other receiving service. Changing the 2 to a 3 gives us an almost 10% chance of 3 customers in the system. Changing the 3 to a 4 gives us a 6.6% chance of 4 customers in the system. As you might have noticed, as the number of customers rises, the probability decreases. In this example for you to try, a quickie oil change shop has an arrival rate of 5 per hour in the afternoon. On average, servicing a customer takes 6 minutes. Arrivals follow the Poisson distribution and service follows a negative exponential distribution. Find the characteristics of the waiting line. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. The 6-minute service time means that 10 cars can be serviced per hour. That is mu. System utilization is 50%, yielding a percentage idle of 50%. Average number of customers waiting is 0.50 and the average number of customers in the system is 1. The average queue wait is 0.1 hour or 6 minutes. The average time in the system is 0.20 hour or 12 minutes. The idle probability is 0.50. There's a 25% chance of one customer in the system. There's a 12.5% chance of 2 customers in the system. There's a 6.3% chance of 3 customers in the system. Finally, there's a 3.1% chance of 4 customers in the system. If this video helped you working operations management problems, please consider liking the video and subscribing to the channel.